Okay, so I'm going to go over the two problems that you just attempted on balancing difficult equations. If you feel like you understood them completely, got them right, then feel free to skip through this on to the next section. So we have what we call hydrocarbon, a compound of carbon and hydrogen reacting with oxygen to produce water and carbon dioxide. We call this a combustion reaction. And these are those situations where we tend to sometimes run into this problem that we discussed. So we do what we always do. We make our chart with our elements present. And we count. We've got 6 carbons, reactants. We've got 1 on the products. We've got 6 hydrogens, reactants, 2 in the products. We've got 2 oxygens in the reactants and 3 in the products. So our most complex compound is our C6H6, so we're going to get those carbons taken care of first. And we can see that by adding a 6 in front of our carbon dioxide, we can address that problem. And we need to address our oxygens. That changes our oxygens to 12 plus 1 is 13. Now let's move on to our hydrogens, because we save oxygen for last. We've got 6 on the reactants. We need 6 on the products. We can easily add a 3 to address that in front of our water. Gives us the 6 we want. I stuck with a red, so I'll keep it red. 3 in front of the water changes our oxygens. So that is a 12 oxygen over here plus 3 more. That's 15. So let's go ahead and change our oxygens to 15. Okay, now we need to reevaluate. We need to say, okay, I've got 6 good. Okay, 6 carbons are good. Hydrogens, 6, 6, those are good. All right, now we get to our oxygens. I need 15 on the right. I only have 2 over here, so is there anything I can add in front of here to make this 15? I don't have any oxygens over here to mess with. I don't have to do any subtraction. That makes this a little easier on me, which is great. So if I put a 7 there, what would that do? 7, that gives me 14. Yikes, that doesn't work. I can't put an 8 there, that gives me 16. So we are stuck. We've hit our brick wall. We know we need to use a fraction, right? So we take the exact amount that we want, we put it over 2. I know 15 divided by 2 will give me the perfect amount. So 15 over 2 is exactly what I need, but I know I can't have a fraction, so that means I must multiply everything by 2. So times 2 eliminates my fraction. Now I multiply everything else by 2. And that will give me my balanced reaction. So I will end up with 2 C6H6 as a liquid plus 15 oxygen gas yields 6 waters as a gas plus 12 carbon dioxides as a gas. Now we want to check everything. I'm going to give myself a green color for checking, because that's good. Alright, so that means I will still have, nope, I will have 12 carbons on the left side. Do I have 12 on the right? Yes, 12. It's 12, 12, 12. What about my hydrogens? Well, 12 is what I'm seeing over here. And 6 times 2 is 12, so those balance. Now our oxygens. 15 times 2 is 30. Alright, do I have 30 on this side? Well, 6 oxygens That looks like 60. Let's do 6 oxygens. And then 12 times 2 is 24. So 24 and 6 is 30. Looks like it worked. So it just demonstrates how this process does work. Let's go to the next one and see how we did. Okay, so let's do this next problem. Another hydrocarbon reacting with oxygen gas to form water and carbon dioxide. A combustion reaction. But we'll do the same steps we always do. Carbon, hydrogen, and oxygen. We'll count up our reactants and products. We got 4 carbons on the reactant side, 1 on the products. 10 hydrogens on the reactant side and 2 on the products. 2 oxygens on the reactant side and 3 on the products. Our hydrocarbon is our most complex, so we'll start with it. We can add a 4 in front of the carbon to get what we want. That gives us 4 and 4 for carbons. We'll do our oxygens, of course. So that gives us 4 times 2 is 8 plus 1. It's just 8 plus 1 is 9. 9 oxygens. Let's address our hydrogens. We've got 10 hydrogens on the left. We can put a 5 in front of our water to get what we want. It gives us 10. Let's reevaluate our oxygens once we do that. So now we have 5 oxygens plus 8. So 5 and 8. It's the 13. Let's see. 13 oxygens, right? Alright, so now let's reevaluate. We've got to get 13 over here. No easy way to do that. We can't put a 6 there, that gives us 12. We can't put a 7 there, that gives us 14. So we know we need 13 halves. Right? So what do? We fix that by multiplying everything by 2. And we rewrite. So 2 CH4, oh no, 2C4 H10 gas plus oxygen. That should have said gas up there. That is 13, right? And I should have crossed that out. Yields 10 waters in the form of a vapor plus 8 CO2 gas. Alright, now let's check our cells. Make sure we're balanced. So, 4 times 2 is 8. And do we have 8 carbons on the right? We do. That's balanced. How about our hydrogens? Well, 10 times 2 is 20. We have 20 on the right. Yep, 10 times 2 is 20. Alright, let's see how our oxygens fared. 13 times 2, that's 26 oxygens. Alright, let's see if we did good on the product side. Let's see, so we got 10 oxygens from the water. 8 times 2 is 16. Sure enough, 10 and 16, that's 26. We are balanced. There we go. So that process works every time.